Hello everybody and welcome to another episode here on AFI Ether. Today I would like to share with you a simple voting smart contract since it has been some time when I last created a tutorial for Solidity with NodeJS and Hardhat. Today we are going to use NodeJS as always 2013 and also Hardhat like in the last tutorial, which I will provide a link for, and the code base is based on that. We will continue to add a new contract over the same repository. My plan with this smart contract is to be able to define a list of candidates when we deploy the contract. We will have voters who can vote using their wallet address, and based on the wallet address we can ensure that one voter cannot vote twice. And we will also add an expiration time so that voting is not possible after the defined timestamp. We will always deploy to a blockchain on the local machine to make sure everything goes all right, and we will create a test for it in JavaScript, and all the code will be published to GitHub. So as always, some considerations. This code is on the fly. I don't have many code samples in preparation, so we will see how it goes with the challenges that are along the way. And the license, it's MIT license. That means that you can reuse and distribute it, and let's have some fun and adapt, because learning should be fun as always. Now, I'm going to code in Visual Studio Code from Microsoft, and I'm having here open my last tutorial, which is on GitHub already, and last time we worked on this simple contract called computations. Now if we want to add a voting contract, we will need to create another file, another Solidity file, and I will name it voting.sol. Okay, and you can see I already have a small warning from my extension, I suppose. Yes, you need to define a license, and you also need to have the Solidity version. So we can copy these two lines and paste them in the beginning of the file. Now in order to start the contract, we will need to define it using the contract, and we can say, yeah, voting. Let's call it simple like that. A voting contract. So what do we practically need? In the first section, I would like to define the variables that the contract will need. These variables will make up the state of the contract, and this state will be stored on the blockchain. And every mutation of the state will happen only on a contract call by some external wallet address. Okay. In this lesson we will also learn how to use structures, so we will define a struct which will hold the candidate details. I'm defining it like that, and let's have the candidate name. Now the candidate name, since there is no string equivalent in Solidity, we will use bytes32, which will be able to store 32 bytes of let's say a string of let's say an array of characters. This means that the name cannot be very long. I think it will be like 20 or 25 characters, something like that. Okay, and for each candidate we also need to have the number of votes, and we will define an unsigned integer for the number of votes. And yeah, I think for now it's all we need for a candidate. We will also need to have the array of the people or the wallet addresses who voted already. So we will have an address voters, an array of addresses, yeah, right? So this will be the voters, and then we will define the list of candidates as an array. So we will have the candidate array candidate. What we have here, identifier not found or unique. I don't know, I think perhaps you need to say public. I don't know. Candidate, identifier not found. But it's here, man, isn't it? Ah, it's, sorry, there was a typo. Okie dokie. And we also need for this contract the timestamp, the time limit that we must not pass in order to vote. After this time limit, voting will be stopped. And it will call it time limit. Okay. And I think that's quite about it related to the state of the contract. So the next step would be to construct the contract, and we will define a constructor for it. And this constructor should take like 2 parameters. So we will have an array of names, candidate names. Okay, and a time limit. Okay, what we have here, the location must be storage or memory. Okay, we will need to add the memory attribute for this one. Memory. Since this bytes thing will not be stored in the state, it will this variable has to be memory, right? So okay, now we will need to assign the time limit that we have, so this particular variable with the value that we pass in the constructor, and we need to perform the initialization of the candidates. In order to perform this, we will need to loop over every candidate name and append that candidate name into the candidates array, and also initialize the votes with 0. So let's see, we will loop, it will be an unint, yeah, I equals 0, I less than I think candidate names dot length. I don't have any code completion, but I suppose it should be length. Okay, and I plus plus. So this is how we define for, and we will say candidates. Okay, we have code completion right here, so that push. So here we will initialize a new structure. In Solidity you have to tell the name of the structure, like candidate, and then use this command, this syntax to perform the initialization of a candidate, and name. So this is very much similar to JavaScript. Candidate names I at index I, and votes will be 0. Candidate names from bytes. Okay, so this has to be 32. We need to have the same variable type everywhere. Okay, we have the time limit, so I think it's constructed correctly. Let's do one thing, let's make sure that our contract will compile correctly. So if we say npx compile, I suppose, no, Hardhat. Compile one Solidity file successfully. So upon successful compilation, we should be able to see the contract JSON with the ABI right here. So this was added correctly. Okay, we are good for the next steps. So for the next steps, what we will need to have? We'll need to have first of all one vote function. Okay. And something like view votes, view winners or votes, winners, whatever. Perhaps we can also sort it in or votes descending way, something like that. And the vote function should be take into consideration two things. This one should validate if the user address has not already voted, and if this time limit is not expired. And I think this should be it for now. Let's see how can we implement the vote function. First, let's declare the function. So we will use the function as in JavaScript, the function keyword, and it will be called very easy vote. And this function will receive, let's say, the index of the candidate index. Okay, and it will be something like public. The function will be publicly callable, and I think that's about it. It doesn't return anything at all. And let's see how we can implement this. First of all, we will need to get the voter address. So if we say something like address voter equals msg.sender. So with msg.sender we can have the person or the wallet which will call this function. Function state mutability, yeah, this I will not add this one yet. Unused local variable. So for now we have two warnings, so let's see how we can implement this further on. The candidate index, so we will do something like if, so we will need to check to do the checkings. If candidate index it's greater than or equal candidates dot length. So if, then we should somehow raise an error. I think there was a error function, and we can say invalid candidate index, right? Error undeclared identifier. Okay, I remember there was an error or something like that you can throw. So let's see on let's Google it. Solidity error throw, something like that. Error throwing, let's say error handling, no. Require, I know require, but we also want, oh, we can use assert. Maybe it will be even easier. Assert candidate index is less than candidates dot length. I think this should be it. And there is also another assertion that we need to make. So we want to ensure that the voter has not already voted. So how can we do that? We will we will need to look for the candidates. So for candidates, let's see if we can find is there any function in Solidity to check if an element is in an array already. Check if element is in array. Let's see. Yeah, I think we need to define another function. Yeah, so let's create another function so to make it easier to use. So we will have the function did vote, and this will be receiving an address voter, and it will be private, and it will return boolean private, and it will return, I think, something like that. I don't remember exactly. Returns. Okay, so you have to say returns bool. Say bool. Expected. Oh, I think it needs parentheses. Okay. Good. And in this function we can do the for loop equals 0 I is less than voters dot length I plus plus, and we can say something like if voter equals voters at index I, we will return true. Otherwise we will return false. Okay, and if we have this nice function, we can say something like assert, and we can say did vote voter equals false. So we can assert that this particular address, which is calling the function right now, did not vote. Okay, so we have this assertion. So we checked the candidate index, and we checked also if the voter did not vote already, and we also need to check if time limit has not expired. This is also particularly important. Okay. Now another question would be, I think we can use also require, right? And this one also has a message. Since I don't have any code completion, I have no idea. So invalid, let's say. I think it's better to use require, so we can also return some human readable messages. Invalid candidate index. In this case, voter already casted the vote. Okay. Let's see if this thing compiles as of now. So let's have a voter equals voters I. Okay, let's see. Wrong argument count for function call. Let's use require and let's see if it compiles. Okay, we have one warning saying that we can use view for this one. Yes, so restricting a function to view makes it makes this really certain that the function does not mute the state in any way. That is, as we can see, the function does not modify any of these variables, so it doesn't modify the state. Cool. Okay, let's do the time limit thing. Require. So in this case, we will require that our time limit is less than or equal to our block time limit. So block timestamp can be block that. I remember there was a block that I will have to check. So let's see on Google. I don't remember exactly which. So Solidity get block timestamp. Is it? How is it? Block that timestamp. Okay. All right. Cool. I think we have all these checks in place before calling or casting the vote, actually. Now everything should be all right, and what we are going to do is to go to the candidate, and it will be like candidates and the candidate index. Okay, so we will get this candidate from there. Data location must be storage, memory, and in this case it will be storage, because we are getting the candidate from the storage and we are assigning it to this variable. And the candidate, in this candidate we will vote equals candidates votes plus 1. Does it work to say something like plus equals 1? I suppose this syntax works. Okay, so we are increasing the candidate votes, and we also need to make sure we add our current address, which is voting into the voters. Sorry, and we say voters that push voter. Okay, we add a semicolon. Let's see if this thing compiles. Okay, so we have this thing compilable. This is really great. Now we need to proceed to have the other function, which will tell us whoever is the winner of this voting campaign. And the winner is only accessible. We want it to make it accessible. Can add here accessible only after the time limit has expired. So this is what we want to do, actually, right? And let's see how we can do this, because we want to get the maximum votes, the candidate with the maximum votes. I think we can do it in a very empirical way. Let's say winner, because we will have only one winner. All right, public, and we will see. I think we will say view returns. Let's say the byte 32. So it will return the name of the winner. Practically, byte 32 or bytes. Okay, and for this we require, as we said, the time limit to be expired. In this case we will say the time limit, we require it to be greater than the block timestamp. Or actually I think there's a small problem here. Time limit Yeah, this one, the block timestamp has to be before time limit. This is not correct. Yeah, and now we will require that. So let's have them in the same position. We will require that the block timestamp will be greater than time limit. Okay, good. Okay, and let's see how we can implement this candidate. We will start by having the candidate name, the first candidate, with like an we suppose that the first candidate is going to be the winner. Candidate equals, and it will be candidates at index 0. And now we can loop integer I equals 1, since the first one is already used by the candidate, so we can start with index 1, and we can say I minus less than candidates dot length I plus plus. Okay, and what we will do, we will say if candidates, so the current candidate, if this current candidate has more votes than the other candidate, that votes, then candidate equals candidate at index y. Okay, so this logic should be quite simple, and I think it doesn't require more than that. And after this loop finishes, we will have the candidate with the most votes. Okay, now what we can do is simply return the candidate name. So we can say candidate.name, and I think this should be quite it. Now, one possibility, one problem, perhaps we can add a comment to check what can we do with candidates who have the same number of votes. This situation can happen. Okay, so the contract seems to be compiling just fine. I think for the constructor memory candidate names, let's have another require here, because we need to have this array at least of a length of 2. Candidate names dot length, yeah, and must have at least 2 candidates. Okay, let's see, this one compiles as well. Compiles as well. Now I think we are quite done with it. We can move on to create the unit testing part and see if our logic that we implemented is all right or not. Good. Now let's create another test file called voting.js, and we can use kind of the same structure as in the other contract that we created last time. We can add this fixture, and we can describe our test suite. We can say voting function. So in here we will have our test cases. Okay, so we will start first with the deployment. So we can use the function, an asynchronous function, to deploy the contract first, since we need to have it in a kind of a test blockchain in the memory, in the computer's memory, in order to test, to be able to test the logic. Okay, deploy voting contract, and we can see how we did it right here. So we can say something like, okay, owner other account. I don't know. Do we need this owner? Yeah, let's copy this and see along the way. And we will say like voting, and we will get the contract factory for voting. And voting, okay. All right, I think we are done for this function. Let's create another, okay, describe. Yeah, let's do the same pattern. So we will describe a test suite. Describe, I don't know, vote for candidates. Okay. So we will add the it. It should deploy a voting contract with let's say 2 candidates. Okay, and this it, okay, async function. We'll have this async function, and we can define the body of the test right here. Okay, first of all, we will use the voting, load fixture, deploy voting contract. Okay, and we will have to add some parameters, right? So first of all, we will need candidate names, which will be an array. And the timestamp, time limit. And we will pass the candidate names right here. So we will say like John Doe, Martin Luther, whatever, and the time limit. Now, in order to pass a correct time limit, we can reuse some code which I already seen in their sample. Practically, they will have something like this. You see, like 1 year or whatever. But we will not need necessarily 1 year. We can add 2 days, or let's say 2 days from 2 days, doesn't matter, 2 days, and this will be like in seconds. It will be 2. Okay. And I remember they used an interesting function. Okay, this one, let's copy this, and we can say time limit equals time that get latest. So this is something like a network helper from the Hardhat, which will get our latest timestamp of the block, plus we will add, so the current timestamp plus 2 days. So the time limit for the voting session will be 2 days. Voting, okay. Proceed with voting. Okay. Let's see if we can test this. npx hardhat test. I don't know if it will pass or not. Of course it will not pass, but failing. Fixture is not a function. Okay. Incorrect number of arguments to the constructor. So somewhere, okay, yeah. But let's do one thing. How can I test? And I want only the voting. Test voting. Test. Let's see some help. Test files, an optional list of files to test. I think we can do something like test voting. Is it? Yeah. Yeah, so I don't want to pass all these tests. I would just want, I'm interested for now in only the voting file. Okay, let's see. So you should, fixture is not a function because we have an incorrect number of arguments passed. And this is exactly true because we didn't pass these arguments from here to the deploy function. Passing them to the deploy function, I think we will need to pass them as an array. Maybe. How is it working in deploy? Unlock time. I have no idea exactly. I think as an array, if I remember correctly. But let's see. Let's run it again. Okay, so we get the same error. Perhaps let's remove the array. Let's see if we manage to do it this way. Okay. Okay, so we have this value John Doe, tralala, and it's not able to convert it to from a string to byte 32. Yeah, this is because we have to practically use another function to make this work. And Hardhat has this function to convert the string to byte 32 value. Luckily, Hardhat has this export, which we can use like this. Const, I think we will need to use this const ethers equals, no, something like that. Require Hardhat. And this ethers library will, oh, we already loaded it, or let's see if it works directly. Ethers, yeah, my code completion doesn't work in Visual Studio Code, but it should have this encode bytes 32 string. Okay, let's do the same for the other one, and perhaps we will be lucky. Okay, we got a different error. Fixture is not a function. This is a very generic one, so I will we will have to see voting JS 24. So load fixture. Fixture is not a function. But what it is? If it's not a function, then what is it? Right? I don't know. Contact. Ah, no. Candidate names. Okay, seems strange. This one is really strange. it looks strange at the beginning, but it's not that strange. So it expects to have just not the caller, the called function. It expects just the function. And in order to perform this, we will have to return another function. So practically inside the function, we need to return another function, which will do the job itself. So we will need to do something like this in order to work. So we'll need to return that particular thing, and I suppose it will work. Oh, again, the same error. But still strange, I don't know. Deploy contract. It shouldn't. This is particularly strange. Deploy, return, async. Very, very strange. Because it shouldn't do like that. Another thing would be that we can maybe remove the async thing. But we get this error, since it means that we are returning some async an anonymous function, and it seems that it doesn't like it. We cannot use it as a fixture. Okay, so I suppose the only option would be to define our candidates in a separate accessible location in like a global way, and the time limit directly into this fixture. Otherwise, I don't think we will be able to use it. So I will return to the async definition, and I will use it like that. Okay, and in the voting, I think we can do something like create a constant of candidates, and we can paste this value, and also the time limit. We can define it right here at the top. Wait, time latest. I don't really like it, but we can do this inside the fixture. Okay, and candidates, we can use the candidates, and time limit will be okay, 2 days. And I suppose we will not need these parameters anymore. Load fixture. Oop, what did I do? Nope, I just want. Okay. These two I will not need them here. Oh gosh, it's the same error. What is going on? I have no idea. Await load fixture deploy. Okay. I don't have to call the function. I just need to supply the function. Let's see now. Okay, so now the deployment works correctly. Good. We have a starting point. Okie dokie. Yeah, what we can do, if we need more candidates, we can create other fixtures. For now, it's totally fine to have this fixture. Perhaps we can add another candidate, like, I don't know, Lucia Morini, something like that, just to have more candidates, and yeah, something like that. Vote for candidates. So we can also use like a get signers. So let's create actually one variable, another voter here, like voter 1, voter 2, voter 3, something like that. 1 voter 2, perhaps voter 4. Let's see. Voting owner. Okay, let's see if this one works. Okay, so the idea is that I want to have a vote for candidates should deploy a voting contract with 3 candidates. Let's say I want to make sure that deployment is fine. Deployment is fine. We should deploy a voting contract with 3 candidates. I think this one doesn't do anything. I just want the load fixture. Okay, the deployment is okay. Now I want to check for the voting. You see we have this condition. Let's start with these requirements. We need candidate names to be at least 2, right? And let's create another case. Should not deploy a single list candidate. And for this one we will for sure need to have another fixture. Deploy voting candidate with contract with 1 candidate. Voting candidates will be, let's say, just the first candidate. Okay, 1 candidate, and this one should crash. Value, just a second, this is not the crash that I wanted. Invalids, no. Candidates, no, I don't need these dots. Right, we can see something like this. This is exactly the message that we want to see. This message comes from the voting constructor, and we defined it right here. Practically this check fails, so there's no point to create a voting session just for 1 candidate, right? So this is exactly what we are testing with this part, and we have to make sure that we can catch this exception and pass the test so it doesn't crash. There is a special syntax from Chai, I suppose, like in this one, in the lock, as we see here. So we need to adapt this part with the expectation that our function will be reverted with an error. And let's see how we can achieve that. Load fixture, let's add it right to replace this one. Load fixture to be reverted with, okay, and this is the message that is going to be reverted with. Okay, let's see. I don't know if it will work. Oh yeah. So practically we are using expect. Expect will call our load fixture like we did in the other example, and it's going to be, it will expect it to be reverted, right? Reverted. This is reverted reversion from the contract itself, and it will revert it with this particular message. If we change the message, it will crash. Okay, and the idea is to make sure we have the same message in both of the places, and we can delete this one. Yeah. Good. Now I can see that our tests are fine. And one beauty of the unit testing, it might be boring, we don't have any UI, we don't have anything at the moment, but it's going to make us see what are the conditions, what is going to crash, or what are the types of tests that we need to do, what are the situations that we need to check, and it will make sure our contract is going to work fine when deployed on the blockchain. Remember that deploying on the blockchain means we don't control the contract anymore, in the sense of we cannot change the code. Once it's there, the contract is deployed to another address in the blockchain, it's immutable, so we cannot change it. That's why we need to make sure it's going to perform well. If we have a buggy contract, then it's going to be a huge amount of problem, right? And for our constructor, I can see another problem that we didn't check. We didn't test the time limit, right? This is for sure not okay at all, because we can practically add a value of 0 here and the contract will not work. We will not be able to vote, we will not be able to do anything, right? So we must ensure that the value that we have there, it's going to be in the future. Okay, this is really important. And let's create a test case for this scenario. First, we need to be able to deploy the contract with a timestamp of 0, let's say. Deploy voting contract with timestamp in the past. Sorry for the long name, but I think it's really better to have it this way. So the time limit, we will say minus 2 days, okay? And we will create the test case. It should not deploy a single, no, a contract. It should not deploy if the timestamp or time limit, let's say, is in the past, okay? To be reverted with, we will add a message later, but let's see how it performs. Let's test it. Yeah. So what happens? We see our test case is failing, and we have the assertion error saying that this should have been reverted. So our expectation from the test is that we cannot supply a date time in the past, yet the contract accepted it and it was deployed successfully. So we need to prevent this. This is really important to avoid. Okay. And how we can do this is to use another require, and we will say that time limit is greater than block that timestamp. Okay. And the message for it, time should be in the future. Okay. And we have this message, and we will also paste it right here. And let's see if now this contract test will be okay. Reason string, tralala. Time limit should be in the future. Something is wrong. Time limit should, yeah, because this is the time limit from the, it refers to this variable, okay, but we want the variable which comes from the constructor. Okay. Now it should work. Yeah, we see that our tests are passing for now. As of now, we only have just the tests for the deployment of the contract. Now it's time to move on to the voting part and to the winner of the voting cast. For this one, we will manipulate the time in order to make sure that it's going to be in after the time limit when we check the winner of this voting session, and we will test every scenario so to make sure that our voting thing is perfectly fine. Time to cast some votes. So we will create another test suite. We describe like so, and we will call it the voting sessions or something like that. And yeah, let's start by first doing a deployment, because for each test fixture we will do a deployment first, and we will do something like const, and I'm not interested in the owner, voter 1, voter 2, voter 3, and we will await the load fixture, and all should be great. Okay. Now how can we vote? And also we will need a voting contract. Voting that vote should be. But I don't remember exactly how can we call it for a certain because I want first to call the vote with the voter 1 and then the voter 2, and to also be able to vote for a specific candidate, right? We have 3 candidates. Let's see, maybe we can find some example right in our repository. Load fixture, get balance. I don't think we have anything like that. I found something. I suppose it will work this way. So we will practically use the voting.connect voter 1. Okay. I think it will work something like to do something like const as voter 1 and with await, because this is awaitable, and let's see, as voter 1 dot vote, and let's say we will vote for candidate number 0, and I suppose we will need to use await. Okay, I'm not sure if it will work. If it's working, then it's perfect. Oh, voting sessions. Now just let me change. Users should be able to vote with their wanted candidates. Okay. So let's multiply this code and try to vote with each voter. We have 3 voters. Let's use all of them to vote, and I think we can we also did the voter 4. Okay, let's also add the voter 4 and voter 4, voter 2, 3, 4, and 0, 1, 2, 0. Okay. Let's see if it works. It works very well. Now based on this scenario, we can try to see that our voting requirements, to check our reversion mechanism, right? So first we will test the candidate index, then we will do the test for a user who already voted, and we will also make sure that our time limit will expire and the vote will not proceed. Okay, good. So let's try to use the same approach. We will check the candidate index. Okay, let's do it like that. Should not be able to vote for an invalid index. I think for this scenario we will just need the voter number 1, and let's do a vote for candidates.length. So for sure this index will not be available, so it will overpass the array and we should see an error, right? Yeah, we already see the message, but in order to pass the test we will need to use the expect part, and we will use the expect.vote to be reverted with and we will add the message. So we will add the message that we got from the contract itself. Now let's see it in action. It should pass. Okie dokie. And we can also test with a minus. Let's say it's voter, no, vote candidates, let's say a -1. Okay, it should fail it with the same reason. Oop, out of the bounds. So we cannot supply, practically it cannot convert to a new unsigned integer because it's a negative value. Yeah, this error cannot be we cannot test this scenario since it will fall on a different level, so this will practically be impossible. We cannot, it's not allowed by design to do that. We can add a big value just like so in order to make sure we are going to pass the test. Good. What is the other scenario that we need to test? Voter already casted the vote. Yes, this is really important. As we can imagine, we don't want the voting session to be frauded in any way. We can, user should not be able to vote twice. So we have the voter, let's say 2, he voted, and then the voter 2 tries to vote with somebody else. Let's see what happens. Voter already casted the vote. Okay, so we see the message. Now we just need to convert it to the expect. Oh, why there were 2 await there? No, that was not good. So let's do the expect that to be reverted with, and we will already, so we will copy the message and let's see. Yes, so the user 2 cannot vote twice, right? It already voted in the line 107. Okay, good. Now let's try to test the other scenario, which will require us to advance the clock of the timestamp to be past the time limit. Okay, so let's do one thing. Let's copy this test case. User should not be able to vote if time limit expired. Okay, so practically we will allow the first two users to vote, and we will add, let's say, voter 3. We will try to make him vote, but after the session expired. And require, I forgot to add a message here, so voting session has ended. Okay, let's add also an exclamation mark, and we will add a message here. Now if we call this like so, it will as voter 3. Oh, I forgot to connect the voter 3. Voter 3. Okay. So we can see that the code, the test, it's expected the assertion to fail, to revert, but it didn't. This is because we didn't advance the timer to a different to force the expiration practically. And in this lock.js, I remember we do have an example for that. Just you see, we can use the increase, time increase 2. So before casting the vote for voter 3, we can increase the unlock time. Okay, we do have the time limit. No, unlock time, it will be just a second, increase 2, so it will be like time dot latest. Oop. Await plus 2 days. Let's see if this one works. It might not work still. But it works because we advanced the time to a different, to the future. So it's pretty easy. So before casting the vote for number 3, we had the time, let's say today. With this statement right here, we increased the time to be in 2 days. So we fast forwarded it in 2 days, and in 2 days it's exactly the time when the session, the voting session, will end. So our contract, seeing that the voting session has ended, it will revert this call back. Okay, so it will not allow any kind of votes for the session. Good. Now another thing which we will need to test is to see the winner of the session, right? So let's practically reuse the same code. It should correctly return the let's say the winner of the voting session, right? So practically we will reuse the code for from the first test case, and then we will try to use to see how is the winner looking like. Okay, voting dot what was the method name? Winner. Await voting dot winner to be const winner name, and we will expect or assert. We don't have assert. Let's look over here. Expect, await expect. Sometimes code completion doesn't work well. Winner name .to be equal to the value. So in this case, how did we vote? So we see there are more votes for the user 0. So for the candidate at index 0, that means candidates dot 0 dot name. No, candidates 0. How is it defined? We can see candidates. Okay, this is already encoded in a base 32 string, and I suppose it should work. Transaction reverted without a reason string. Okay, let's see our voting contract. The winner. So why did it revert? We can see we have a require block right here, which doesn't return any message. So we cannot see the winner unless the voting session is complete. Okay, so we can say voting session is not ended. Okay, so in order to see the winner, we again need to advance the clock. So we will use the same syntax as here. Everybody has voted, voting session has passed. Let's see. Perfect. Okay, and let's see also the scenario for this part. So we cannot see the winner unless the voting session has ended. So that means the time limit has expired, and we will add, so it should revert, checking winner should revert if voting session has not ended. So everybody will vote. We will try to expect. We will use the expect statement like we did before to be reverted with, and this is the message. Let's see how it goes. Beautiful, really beautiful. So we have also this scenario in place. Practically we kind of have everything we need for now. The candidates with the same number of votes, yeah, it might be a bit tricky, but I think it's more outside of this tutorial and outside of the scope for now, because since this is a really edge case, in a real scenario, we will have thousands of votes, and I don't think there will be someone who has the same number of votes as somebody else. So I think we can leave it like that for now. I think we have a lot of information, and already the test file is kind of big, I would say. Although I wouldn't say it's that complicated, I think it looks good, and we have most of the scenarios in place. Of course, the smart contract itself can be even more extensive, more complex than that, but I tried to keep it as simple as possible. And I hope you find it useful, and I think it should be like a cornerstone in coding, in a Solidity coding, since it's something that we will need to use in any kind of smart contract. And I hope you find it really useful. As always, you can go to my blog itself. You can find many tutorials out there, and if you are interested, you can also subscribe to my newsletter, and I hope it will be of good use to you. And you can also check my distributed these decentralized applications on this node right here. You can use the contacts. For now I only have a contacts for the Ethereum Arbitrum network, and it should work with MetaMask and Coinbase. And yeah, hopefully it will be interesting for you to use. And if you have any questions, let me know. And if you like this video, don't forget to subscribe and write to me in the comment section if you have any questions or suggestions for improvement. Thank you very much.